looked at, the denominator had factors with only multiplicity 1. There were no repeating factors. And there's a special way we have to deal with that. So let's look at an example. Let's say I have 5x squared plus 3x minus 6 over, this is going to let this already be factored. Now, this is not a quadratic per se. I mean, it's squared, so officially, if I multiplied it out, it would be quadratic. But the factor is linear, but it occurs twice. So we need to take into account the possibility that I'm going to have a fraction over x plus 1, or I might have a fraction over x plus 1 squared. So I want to look at both of those cases. So I'll say a over x plus 1, and then I'll have a b over x plus 1 squared. I don't have the bx plus c because the factor is not a quadratic. And then my last factor is x minus 3, and I'll stick a c on top because it's linear. I need a constant. So what this means is the numerator, if I bring these all together, I will have a times x plus 1 times x minus 3. I will have b times x minus 3. And I will have c times x plus 1 squared. And this has to equal the numerator on the other side, which is 5x squared plus 3x minus 6. So let's see, what are some convenient x's to choose? I'm going to choose x equal -1. That'll make this go to 0 and this go to 0. So the only thing I have left, -1 in here gives me a -4. So -4b is equal to, if I stick a -1 in here, I will get a -4. Which means b is equal to 1. Cool. Now, the next convenient number, let's try 3. If I use 3, then the a expression and the b expression go to 0. The only thing that's left is the c. If I plug 3 in here, I get 3 plus 1 is 4, squared 16. So I'm going to get 16c is equal to, if I stick 3 in here, I will get 48. Which means c is equal to 3. Last, I need one more. I don't have any more pretty roots, anything that makes it goes to 0, so my next best thing is 0. I like 0. So if I plug a 0 in, let's see, this will be -3a plus 0 in here is a -3b. 0 in here gives me a c, and 0 over here is sweet, gives me a 6. A was, where's A? Oh, that A is what we're looking for. B is a 1, so I have -3a. B is 1, so I have -3. C is 3 plus 3. Well, that's cool. -6, those will subtract off. -3a equals -6, which means a equals 2. So my fraction, 5x squared plus 3x minus 6 over x plus 1 squared times x minus 3 can be written as, there's a 2 over x plus 1 plus, where's my b is a 1 over x plus 1 squared, and my c was 3 plus 3 over x minus 3. And these will all be, that'll be a natural log, that'll be -1 over x plus 1, and that'll be another natural log. So this would, if I had to integrate this, it would be straightforward. Now, here it looks just horrid. Now, what happens if you have other multiple ones? Okay, let's look at the really gross one. We're not going to actually crank it out, but I'm going to show you how to set it up so you get the idea of what all the rules are. So let's say I have x squared plus 4 squared times x plus 2 cubed over, I don't really care what's on top, 1. If I were to set this up to break it up into smaller fractions, first I'm going to deal with this one. It's a quadratic, and there's 2 of them. Since it's a quadratic, I need linear on top, so I will have ax plus b over x squared plus 4. Now I need to deal with the x squared plus 4 squared. I need another linear term, b, c, x plus d. Now I've got x plus 1 cubed, so d, I have an e over x plus 2 plus f over x plus 2 squared plus, you seeing this, plus g over x plus 2 cubed. That would be how we would have to set it up if we had this grotesque bottom denominator. So just remember, if you've got multiple roots, or multiple factors, you need to look at each possible power and put the appropriate variable on top.